The other day I was asked, what is a fire damper? And I thought to myself, you have to explain that. When you imagine a room, there is a door. This is the fire door through which you enter. In principle, the air must do the same. The air travels into the room through an air duct. To close the air duct again, there are similar to the fire door fire dampers. They close the air ducts and ensure that in the event of a fire, the fire does not spread from one room into the other. While a fire door should always be closed, a fire damper must always be open. A big difference to the fire door is not only being open instead of closed, but also the shape. Fire dampers are also available round, while fire doors are only available square. The company Promat has done something interesting. They took two fire dampers of the series FK2EU and installed them in the furnace and looked at what happens when installed correctly and what happens when installed incorrectly. And we see the furnace of the company Promat and the rough experimental setup. We see here the built-in sample. Above and on the side there are measuring points. Measuring points are there to record the temperature via the fire test. Now, the simulation of the closing process, the triggering, so that one can see that the fire damper closes when it has to. Next, here is the pattern, which is installed correctly. With the circumferential mortar bed, and in the close-up from the inside, we see that the intumescent strip is intact here. In return, we now see the incorrectly installed specimen, where above and on the side instead of the mortar bed there is ceramic wool inserted. And here we see the defective intumescent strip, and then we look at what happens in the fire test. We can see the measuring points here, visualized by the software, so that one can see the temperatures of both fire dampers on the screen and then compare them with each other. On the left, we see the incorrectly installed fire damper, and on the right, the correctly installed fire damper. And already after about 5 minutes, you can see down here at the housing that there is smoke coming from the missing intumescent strip to the cold side. And also here, at the front of the hand lever, you can see very nicely that the mortar bed where ceramic wool was installed begins to fail and large amounts of smoke enter the room. Actually, the smoke is the more critical medium than fire, because most people die from smoke and not from fire. The correctly installed fire damper also has a significantly lower housing temperature than the incorrectly installed fire damper. And if you now take a look at how here in minute 15 the intumescent strip swells out, then you can see that it is consumed much faster than with the fire damper, which is installed correctly. Interesting, from minute 30 on you can see that the ceramic wool burns through and you can look into the oven. You see the red glowing that equals about 800 degrees at this minute in the experiment, and that the intumescent strip swells more and more comes from these temperatures. Comparing the wrongly installed damper with the properly installed fire damper, there it is significantly less. Here too, there is of course some frothing to be seen, but the difference is striking, especially because the smoke of the not correctly installed fire damper protrudes significantly more than of the correctly installed one. In summary, it can be said that the fire damper, which is incorrectly installed, exceeded the limit temperature of 180 degrees after about 20 minutes and thus failed, while the correctly installed fire damper has only reached a temperature of 80 degrees after approximately 60 minutes. This is also the reason why you need to check your fire damper for function and see that all parts are intact and that the installation has been implemented in accordance with the operating and installation instructions.